Hello students, our topic for discussion today is reaction of oxygen and water with non-metals. Reaction of oxygen and water with non-metals. So we are studying the chapter metals and non-metals. So in that today we are going to discuss reaction of oxygen and water with non-metals. So let's start. So first thing is non-metals react with oxygen. There is reaction between non-metals and oxygen, and when non-metals react with oxygen, the product which is formed is non-metal oxides. So let us take few examples. First one is carbon. When burned with oxygen, it forms carbon dioxide. It forms carbon dioxide. Like carbon is taken like in a solid form, it can be like coke or wood, in any form. Plus when it burns in presence of oxygen, it forms CO2, which is gas. And then let's take second example, which is like sulfur, which is another non-metal. When burned in presence of oxygen, it gives sulfur dioxide. Again, here sulfur is taken in a solid form, and oxygen, presence of oxygen, it is burnt and gives SO2 gas. And then let's see third example, phosphorus. When it burns in presence of oxygen, it forms phosphorus pentoxide. It's like P4, which is white solid, O2. I'm balancing here equations. P4O10, which is solid. And this product which comes, it is also known as phosphorus sun, because phosphorus is a non-metal which is very reactive with oxygen. So when it reacts, it forms like a phosphorus sun. So now what we'll do, this you have seen quite common, how carbon burns with the oxygen. In the winters, people burn wood. But I want to show you two videos where I will show you how sulfur burns with oxygen and how it forms sulfur dioxide. And the second video I will show you how phosphorus reacts with oxygen and it forms phosphorus pentoxide, and why it is known as phosphorus sun. That also you will come to know. So let's watch these two videos, then we'll proceed further.
The first thing we need to do is create a pure oxygen environment. To do this, I'm adding a little bit of bleach to a flask, and then carefully adding in some concentrated hydrogen peroxide. The hydrogen peroxide and bleach react to form oxygen gas and sodium chloride. Once it's done reacting, I put a glass lid over the top to keep the oxygen from escaping. First, I'm going to show you what burning sulfur looks like in atmospheric air. First, the sulfur melts, and then it begins to slowly burn with a small blue flame. If we start burning some sulfur, and then quickly put it into our pure oxygen environment, it burns with a very, very bright flame. This is much different than when it's just burning in normal atmospheric air. After I did this just by holding my spatula, I thought that I would attach a wire to the top of it and lower it down even closer to the bottom of the flask. As you can see, all the sulfur is gone because it has been converted into gaseous sulfur dioxide. Here's another attempt using the wire that I was talking about earlier to lower it even lower into the flask, and you can see that it burns even brighter with a very, very large flame. Thanks for watching.
A piece of white phosphorus is dried and placed in the glass deflagrating spoon. The element is lowered quickly into a flask of oxygen. White phosphorus is stored under water because it is spontaneously flammable in air. The element soon ignites and burns vigorously in the oxygen. This reaction is often referred to as the phosphorus sun. The bright white light that comes from phosphorus burning is sometimes used in flares and other applications.
Now, as we have seen how non-metal oxides like sulfur dioxide and then carbon dioxide and then phosphorus pentoxide are formed when the non-metals react with oxygen. And hope you learned from previous videos where I showed how sulfur reacts with oxygen and phosphorus reacts with oxygen. Now the point is, when these sulfur dioxides, carbon dioxide and phosphorus pentoxide, these are forms, they all are acidic in nature. They are acidic in nature. And when these carbon dioxide or sulfur or phosphorus pentoxide or even nitrogen dioxide, when they react with water, now we already seen their reaction with oxygen, now we will see their reaction with water. They are acidic, and when they react with water, they form acid actually. Like, we'll take one example, like CO2. When it reacts with H2O, it gives H2CO3, which is carbonic acid. And when sulfur SO2 reacts with water, it gives H2SO3, which is sulfurous acid. And when nitrogen NO2 reacts with water, it gives nitric acid HNO3 plus nitrogen monoxide. So this is like, for balancing purpose, we balance this equation, and this is what? This is nitric acid. So you may be wondering how we came to know about these solutions which are formed, they are acids. There is a simple test which you might have already studied. What is that test? That is red litmus test. That is what? Red and blue litmus test. So what happens here? When red litmus is dipped in solution, any of this solution, and if it turns blue, that means it is basic, right? And when blue litmus turns red, that means it's acidic. So now we will see one more video how they test about these oxides, non-metal oxides are acidic or basic in nature. And one more thing before starting the video, it's very important to understand the non-metal oxides, such as sulfur dioxide or nitrogen oxide or nitrogen oxide, sulfur dioxide or carbon dioxide. They are all responsible for acid rain. All responsible acid rain. They dissolve in water in the clouds. They dissolve in water in clouds and form acidic solution. And this acid rain damages when they fall, these acid rains when they fall on the rocks, buildings, and they are very harmful for wildlife also. So because of this acid rain only, our Taj Mahal has the shining has been damaged because of this acid rains. So these metal oxides which are formed, they are also responsible for acid rains. So now we will see how we test they are acidic or basic with the help of red litmus paper and blue litmus paper. We'll figure out how it is acidic in nature. So watch this video, enjoy this video and learn from this video.
Place a small piece of phosphorus on a china dish. Burn the phosphorus with the help of a glowing splinter. Cover it with an inverted gas jar. You will observe that the gas jar gets filled with white fumes. Make the gas jar upright and pour some water into it and shake well. The white fumes dissolve in water. Now put a few drops of blue litmus solution into it. The color of the litmus changes to red. It shows that the oxide of phosphorus is acidic in nature. This experiment proves that non-metallic oxides are acidic in nature.
So dear students, as we saw the reaction of oxygen with non-metals. We saw when non-metals react with oxygen, they form non-metal oxides. And then we also saw how these non-metal oxides are acidic in nature and how these non-metal oxides, when they react with water, they form acids. Like carbon dioxide with water forms carbonic acid, sulfur oxide with water forms sulfuric acid, and nitrogen dioxide with water forms nitric acid. So we saw this reaction how they form acids. So now we will see the reaction of non-metals with water. You will be surprised that non-metals do not generally react with water. Means non-metal plus water reaction does not happen. Hope I am clear. Obviously there are some exceptionals like fluorine is exceptional, but generally the non-metals do not react with water. And there is a reason for that. What is the reason? If you see, we have seen the definition. The definition of non-metal was that non-metals are electronegative, right? We had seen the decision that like non-metals are electronegative, so unable they are unable to break the bond between hydrogen and oxygen in water. So if you remember, the definition of non-metal was they are electronegative in nature. Electronegative means they are electron acceptors. They accept electron. We had seen that example, how they accept electron. So when they accept electron, that's how they become electronegative. So non-metals are electronegative. So they are unable to break the bond between hydrogen, oxygen, and water. Because if they have to break the bond, they have to actually donate the uh, electron, while as they themselves are acceptors of electrons, so they won't be able to do that, so they don't make any bond with hydrogen. So that is the reason they are not able to break the bond between hydrogen and oxygen in water. So the non-metals cannot reduce hydrogen by donating electrons, because if he wants to react with hydrogen, it has to donate, and that it cannot do because itself is the acceptor of electrons. So thus non-metals do not react with water. So just to recap what we studied today, we studied a reaction of oxygen. We studied reaction of oxygen and water with non-metals. We saw how non-metals react with oxygen. There is reaction between non-metal and oxygen. They form non-metal oxides. And then we saw videos also how sulfur reacts with oxygen, how phosphorus reacts with oxygen. And then we saw that these oxides which are formed when they are combined, mean these oxides, these non-metal oxides, when they react with water, they form acids. Then we saw carbon dioxide example and sulfur dioxide example also, how they form carbonic acid, sulfurous acid, and nitric acid. So although non-metal oxides react with water, but 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 non-metals themselves don't react with water. Non-metal themselves don't react with water. Obviously there are some exceptional which I told. So no, and why they don't react with water, there's a reason behind that. So if you remember, the definition of non-metal is they are electronegative. They are electronegative in nature. That means electronegative means they accept electron. So that's how they become electronegative. While as the metals, they react with water. Why? Because they are electropositive. Electropositive means they donate electron. When they donate electron, they readily break this hydrogen and oxygen bonding. While as here, if they wants to react with hydrogen, it has to donate electron. But non-metals cannot do that because they themselves are acceptors of electron. They can't donate electron. So if they can't donate electron, they can't break this bond. If they have to break this bond, they have to give this electron to the hydrogen, and that's how the reaction takes place. So thus non-metals do not react with water. I again repeat, non-metals do not react with water. Although non-metals react with oxygen and their oxides, non-metal oxides, they react with water and they form acids. So this is the end of class today. Thank you very much.